In this video, we're going to be working with graphs and answering questions like these ones, where I give you the equation of a graph and coordinates that that graph goes through, and we've got to find the values of those constants. I'm going to give you one big tip to start with, that for any of these graphs questions, a sketch is really important. It makes it clear in our own head what we're aiming at, and in doing a sketch, we might notice some things about the coordinates that are given to us. All right, let's do this first example. This equation of a line first. This could have been given to us at GCSE, equation of a line. So the coordinates 1, 1 and 4, 7. Remember that when we are sketching coordinates, they just need to give a rough idea of where that coordinate is. They don't need to be exact. Line through the two. Okay, from my knowledge of equations of lines, I know that this one is the gradient of the line and this one is the y-axis intercept. Which one of those can I get first? I think the gradient of the line, if I use this right angle triangle here, how far does it go along? It goes from 1 to 4, that's 3 along, and from 1 to 7, that's 6 up. So the gradient is 6 over 3, which is 2. So we have y equals 2x plus b. How do we find b? Let's plug in this coordinate. So 1 is 2 lots of 1 plus b. So 1 is 2 plus b. We get that b is -1. So overall, our equation is y equals 2x minus 1. We can check that by using the other coordinate. So if we plug 4, 7 in, is it true that 7 is 2 lots of 4, take away 1? It is. So I'm happy with that one. Okay, next question. This one's slightly harder. We've got a quadratic. Let's sketch it. We have that it goes through 0, 5, that's on the y-axis. 5, 55, let's put it up there. And 10 along and 5 up. 10, 5. Okay, how good am I at drawing parabolas? Oh, a bit funky on the right, but that'll do. Okay, before I talk about those points, what do you notice about them? Take a look at that graph, and what do you notice? Okay. Something I've said already is that that 0, 5 is on the y-axis. So that gives us that E is 5 straight away. Fab. Next. When I drew these, I noticed that 0, 5 and 10, 5 were at the same height. Maybe that'll be useful. Also, that 555 is exactly halfway between the others horizontally. So because of the symmetry of the parabola there, I know that 555 is the maximum point. Now those things that we just said, we might be able to use those to find these other two constants in sneaky little ways. For example, I could use something to do with the completed the square form and use this maximum point and then put it back into the form that I need. Or if I imagine that whole thing moved downwards by 5, then these two red ones, would become the roots of that parabola. And so I'd be able to use the factorised form of the quadratic and use those roots. And then at the end, move everything back up. Very fancy there. For this example, I'm not going to use those fancy methods. I'm just going to plug these coordinates in and set up some simultaneous equations. And this method should always work. But maybe you want to try those fancy versions yourself. Okay, 555, let's plug that in. So we have that 25c plus 5d plus 5 gives 55. Let's tidy that up by taking away 5 from both sides. So 25c plus 5d equals 50. So we've used that one. And the other one, 10, 5. So if I plug 10 in, I get this. And that needs to equal 5. Again, take away 5 from both sides and get 100c plus d, 10d equals nothing. Right, let's simplify those up a little bit more, because I can divide the top one by 5 to get 5c plus d equals 10. And I can divide the bottom one by 10 to get 10c plus d equals 0. There we go, nice and simplified. Now we've got to solve these simultaneous equations. So if I do equation 1 take away equation 2, I'm going to get negative 5c equals 10. So c is negative 2. How do I find d now? I think I'm going to use the first equation. And if I plug back in c is negative 2, I get negative 10 plus d equals 10. So d is 20. And I think that's everything there. So y equals negative 2x squared plus 20x plus 5. All right, something that I forgot to mention before, because it's a sad parabola, I'm happy that that first value there has come out as negative to make it the sad parabola. How do I check that? I could plug in those points again to check that it works. That's what I might do in an exam, but because we're not in an exam, and as you're practicing, you can do this, we can plug it into Desmos. So if we plug in negative 2x squared, what was it? Negative 2x squared plus 20x plus 5. Oh, wrong one. Plus 20x plus 5. Going to need to zoom out here and check that it goes through those points. So it definitely goes through 0, 5. It definitely does it go through 10, 5? Yeah, it does. Fab. And all the way up at the top, let's go up, let's go up, let's go up. Does it go through 555? Yes, it does. Fantastic. We found the correct graph. Oh, that's magic there, I think. We've just done lots of algebra, and yet we've got a graph here that works. I think that's a bit of magic. Beautiful. All right, last example here. This exponential. Right, again, I'm going to do a sketch, obviously. I wrote it in gold to start with. It was really important. So this exponential graph goes through 3 along and 0.8 and 6.4. So this sketch is already telling me that this exponential is exponential growth rather than exponential decay. This could have been exponential decay here, but this one is going upwards. So it's growing. That tells me that G is going to be more than 1. It's going to be bigger than 1. If G had turned out to be if the graph had turned out to be exponential decay, then I would have known that G needed to be between 0 and 1. But no, it's growth, so G is going to be bigger than 1. cross fingers. Okay, how do we do this? Let's just plug the values in and see what we get. So this first one gives us that fg cubed is 0.8, and the second one gives us that fg to the 6 is 6.4. Now there are some nice ways of solving simultaneous equations like these ones that are different to the other ones. If I take equation 2 and divide it by equation 1, then those f's are going to cancel out. Let's write it out fully first. We've got fg to the 6 divided by fg cubed is 6.4 divided by 0.8. Those f's are going to cancel out, and 3 of the g's are going to cancel out to leave g cubed is 8. Oh, that's an easy one for you. G is 2. Fantastic. Turns out to be easier than the quadratic one, it seems. Now let's use that and plug that back in. Let's use equation 1 to then give us that if g cubed is 8, then 8f is 0.8 and f is 0.1. So altogether we have y equals 0.1 times 2 to the power of x. Fabulous. Those are my 3 examples. So I'm going to leave you here with a chunk of practice for you to do on your own. You can see there that there are 2 lines, 2 quadratics, 2 exponentials, and for you to figure out on your own, 2 logarithms. To reinforce one of the tips that I said before, especially with those quadratic ones, when you do the sketch, try to notice some things about what's going on. That could really help you to save time with your workings. Good luck with all of that practice.